Black holes, mysteries of gravity. When we think about the universe, we often imagine shining stars, colorful nebulae, and vast galaxies glowing in the darkness. However, some of the most fascinating objects in the universe cannot be seen at all. These mysterious objects are called black holes. A black hole is a region in space where gravity is so powerful that nothing can escape from it, not even light. Because light cannot escape, black holes appear completely dark, making them one of the most puzzling and intriguing phenomena in the cosmos. The idea of black holes comes from the work of scientists such as Albert Einstein, whose theory of general relativity explains how gravity works on a cosmic scale. According to this theory, massive objects bend space and time around them. When a very large star reaches the end of its life, it can no longer support itself against its own gravity. The star collapses inward, and if the remaining core is massive enough, it continues collapsing until it becomes extremely small and dense. This process often occurs after a powerful explosion called a supernova, during which the outer layers of the star are blasted into space while the core shrinks dramatically. If the core is heavy enough, it forms a black hole. At the center of a black hole lies what scientists call a singularity. This is a point where all the mass of the black hole is compressed into an incredibly small space, creating a region of extremely high density. Surrounding the singularity is the event horizon, which acts as a boundary. The event horizon is often described as the point of no return. Once anything crosses this boundary, it cannot escape the black hole's gravitational pull. Even light cannot escape, which is why black holes remain invisible to direct observation. The behavior of matter and energy beyond this boundary is still not fully understood, making black holes one of the greatest mysteries in physics. Even though black holes cannot be seen directly, scientists can detect them by observing their effects on nearby objects. When a black hole is near a star, its strong gravitational pull can draw gas and material away from that star. This material forms a spinning structure known as an accretion disk around the black hole. As the material spirals inward, it heats up due to friction and releases large amounts of energy in the form of light and radiation. This glowing disk can be detected by telescopes, allowing scientists to identify black holes and study their behavior even though the black hole itself remains hidden. Black holes come in different sizes, and each type tells a different story about the universe. Stellar black holes are formed from the collapse of individual stars and are usually several times more massive than the Sun's supermassive black holes. On the other hand, are found at the centers of galaxies and can be millions or even billions of times more massive than the Sun. At the center of our galaxy, the Milky Way, there is a supermassive black hole known as Sagittarius A star. This enormous object influences the motion of stars and gas in the galaxy, playing a key role in maintaining its structure. Scientists believe that most galaxies, if not all, contain such supermassive black holes at their centers. One of the most fascinating aspects of black holes is how they affect space and time. According to general relativity, gravity can slow down time. Near a black hole, this effect becomes extremely strong. If a person were close to a black hole, time would pass much more slowly for them compared to someone far away. This effect, known as time dilation, has been confirmed through experiments using precise clocks on Earth and in space, but near a black hole, it would be far more extreme. This means that black holes do not just pull objects in, they also change the way time itself flows. Another strange and dramatic effect is known as spaghettification. As an object approaches a black hole, the difference in gravitational force between its nearest and farthest parts becomes very large. This difference stretches the object, making it longer and thinner, like a strand of spaghetti. This effect would be extremely dangerous for any object or person that gets too close to a black hole, as it would be stretched and compressed by the intense gravitational forces. For many years, black holes were only theoretical predictions, but modern science has provided strong evidence that they exist. In 2019, scientists working with the Event Horizon Telescope captured the first image of a black hole shadow. This historic image showed a bright ring of light surrounding a dark center, which matched the predictions made by Einstein's theory. It was a major breakthrough that confirmed many ideas about black holes and opened new possibilities for research. Black holes can also collide and merge with each other, creating even larger black holes. When this happens, they produce ripples in space known as gravitational waves. These waves were first detected in 2015, marking another important confirmation of general relativity. Gravitational waves provide scientists with a new way to observe the universe, allowing them to study events that cannot be seen with traditional telescopes. Another important idea about black holes was proposed by Stephen Hawking. He suggested that black holes are not completely black but can slowly emit energy, known as Hawking radiation. Over extremely long periods, this process could cause black holes to shrink and eventually disappear. Although this process is very slow and has not yet been directly observed, it is an important concept that connects gravity with quantum physics. Black holes also play a major role in shaping galaxies. Supermassive black holes at the centers of galaxies can influence the formation of stars and the movement of gas and dust. When they consume material, they can release enormous amounts of energy, sometimes producing powerful jets that extend far into space. These jets can affect the surrounding environment and even regulate how new stars are formed. In this way, black holes are not just destructive objects but also important for the growth and evolution of galaxies. In simple terms, black holes are regions of space where gravity becomes so strong that nothing can escape. They form from the collapse of massive stars and can grow by absorbing matter or merging with other black holes. Even though they cannot be seen directly, scientists can study them through their effects on nearby objects and the radiation produced by material falling into them. Black holes challenge our understanding of physics and push scientists to explore new ideas about how the universe works. The study of black holes continues to be one of the most exciting areas of modern science. With advanced telescopes and new technologies, scientists are discovering more about these mysterious objects every year. Black holes help us understand extreme gravity, the behavior of space and time, and the evolution of galaxies. They remind us that the universe is full of mysteries waiting to be explored and understood, and each new discovery brings us closer to uncovering the secrets of the cosmos. If you found this explanation of black holes helpful and fascinating, do not forget to like the video, share it with your friends, and subscribe to the channel for more engaging and easy-to-understand content about space, science, and the wonders of the universe.